behalf of RBCS, RBCS Australia, RBCS New Zealand, and Software TestWorks, we welcome everyone today to this webinar on advanced software testing with decision tables. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States, Australia, New Zealand, and Sri Lanka, with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1 and 2, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA. I'm also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, feel free to submit them throughout the presentation at any time via your webinar interface. There is no need to ask for copies of the presentation because the presentation is already posted on the web at www.rbcs-us.com. If you are having problems with either the audio or visual components of this webinar, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online, or if you are dealing with an unreliable connection, please download the slides of this presentation from the basic library, which is on the resource page of www.rbcs-us.com, and be sure to use the telephone to connect rather than voice over IP. That said, pretty unusual for people to have difficulty using this facility. It's proven quite reliable. Okay, so down to business. Today's presentation is the first in a multi-part series on advanced software testing. We'll do a few of these, and at least three. I haven't really decided exactly how many. I'm going to keep doing them until I either run out of ideas or people tell me they've had enough, or with some other reason we stop having them. Now, we're not going to do only these webinars on advanced software testing techniques. We'll interleave these with some others, but they will be a periodic feature in the webinars. The material that I'm going to cover, at least initially for the first, I don't know if I did a dozen of them, I'd have enough material for that, will come from my popular books, Advanced Software Testing Volume 1 and Pragmatic Software Testing. And in this particular webinar, we are going to start with decision tables. Now, I chose to do this series of webinars on advanced software testing techniques because there are so many powerful test design techniques that have been developed over the last 30 years, and yet so few of these are in regular use. And in a lot of cases, people simply aren't aware of the techniques, or they don't know how to use the techniques, or they can't identify situations where they can use the techniques. So this series of webinars will help address those issues. It's kind of like if you were a master carpenter or something like that, or wanted to be a master carpenter, to go through a whole series of webinars on how to use various kinds of carpentry tools. That's kind of the way to think of this series. Okay, so we will start with decision tables and the application of decision tables for the testing of business logic. Now, that's an important point to start with. When you're testing with decision tables, you are focused primarily on the testing of business logic, not on user interfaces, or typically on other internal interfaces between components, or on interfaces between the application and the operating system or database management system, or other sorts of cohabiting software or hardware or something. It's really implementation of business logic within the system is the sweet spot, if you will, for this technique. Okay, so As I said, we're starting a series of webinars here, excerpted in this case from Advanced Software Testing Volume 1. This is a book for test analysts and test engineers. We also offer a course, Advanced Test Analyst course, both live and e-learning versions, and this material is part of that course. Of course, a very small part of the course. The live course is 5 days long, so what we're going to cover here is about an hour. So give you a feel of the kind of the depth of coverage in that course, though it's all of a similar level of intensity. Now, I mentioned testing of business logic, and rather than testing of input field validation. So if you're testing input field validation, and by this I mean does each field on a screen or other form of input accept values it should accept and reject values it should reject, then the equivalence partitioning and boundary value analysis are going to be the more useful techniques there. Now, I wouldn't really consider those necessarily advanced software testing techniques, so there are some advanced things that we can do with those. But I'm going to assume that you know what I mean by an equivalence partition and a boundary value, and that it's also fairly clear how one would use those for testing input validation by putting in the minimum and maximum allowed values, for example, into a field, and then just outside of those legal ranges, testing to see what happens there, and testing with things like 0 and other kinds of special values. So that's input validation, and that's really not what we're focused on here. What we're focused on with decision tables is what happens, what does the system do after it gets those inputs, and presumably they have been validated, and now it has to decide what actions to take. And of course, this is the application solving the problem it was written to solve. I'm not saying that the input field validation code is unimportant. Obviously, it's very important. It's important from a security point of view and a usability point of view, and from a functional point of view. And certainly, large percentage of the code in interactive applications does indeed handle input field validation. But that's not why people create software. People create software to implement some sort of business or problem solution logic, and that's really what we're focused on with decision tables. Now, there are a couple other techniques that are very useful for testing business logic, state-based testing, and use cases, and those will be the subject of at least 2 subsequent webinars. And as I said, there might very well be other ones here if the mood takes me and this proves popular and useful. But here we're going to cover decision tables and a related concept that you might run into from time to time called a cause-effect graph, which is not something that I think is used as much, but it is equivalent, and it would be a good idea to understand how to deal with one should you come across one. Okay, so decision tables conceptually are about testing the rules that govern the handling of transactional situations. So let me describe what I mean exactly by a transactional situation. A transactional situation is a situation where a set of conditions prevail at a given moment, and based on that set of conditions, the system can decide what action or actions to take and what action or actions not to take. And that the conditions are influenced very little, if at all, by things, events which have happened in the past and conditions that have prevailed in the past. In other words, each transaction is independent of previous transactions. So an example of this would be a ATM or automated teller machine. Each customer's interaction with the ATM is insulated